Today we're going to take a look at scanning a 1-2-3 block with an Artec Space Spider. So we're using Artec Studio 15 here, which was just released. And what we really wanted to do was do a very simple gauge repeatability and reproducibility study, or a GR&R study, with the Artec Space Spider in Artec Studio 15. So to do this, we decided to use a 1-2-3 block for the analysis. Now, a 1-2-3 block, when it comes to 3D scanners, is one of the most difficult things you can do a GR&R study on because of how flat and how uniform the part is. Traditionally speaking, with most 3D scanners, this type of part is very difficult to align, as well as very difficult to get repeatable results on because of all the uniform cylinders and the flat planes, and not a lot of external surface geometry that can really be used for referencing when aligning all of the individual frames up from the scan file. So to make this process even more difficult, we are making sure that when we do all of our alignments, we're not using any external referencing data whatsoever. So we're just using the 1-2-3 block here, cutting out any sort of table material that we could use for referencing, and really just focusing on, in the worst case scenario, how is the Artec Space Spider going to perform when we're discussing repeatability and accuracy in its scan data. So we did this 6 different times, and each time we did scan the part in 3 different orientations, as well as used the same processing for creating our scan files. So the same number of global registrations, the same value inside of those global registrations, as well as our outlier removal processes, and the same resolution in the Sharp Fusion file that was created. So you can see we're just running through here and running our global registration, as well as our outlier removal process to get rid of all of the unwanted noise around our scan file. So at this point, we're going to go ahead and process this out at a 0.3 millimeter resolution, and we'll do this 6 times. However, we're just going to show it once here in this video. We're going to take this part into Geomagic Control X and analyze it a little bit further, taking measurements on the 1 inch, the 2 inch, and the 3 inch mark, putting those in a spreadsheet, and then taking a look at the results. So here we're just going to show the video where we run all 6 of those files so you can see them here live. We are going to speed up through it. And while that's going, we'll talk about a couple of the key factors that we're going to be considering here in this video. So the first one that I already mentioned, which is a 1-2-3 block, is really a great test of alignment performance inside of Artec Studio, as well as the overall accuracy you can achieve in pretty much any sort of scenario with the system. The second thing that we're going to focus on is really what are the takeaways from that accuracy, because there's 2 different forms of accuracy that we can consider. One is going to be positional accuracy based off of reference CAD, which will be our 1 inch, 2 inch, and 3 inch values. And then there's going to be accuracy based off of overall scan noise, which we're using our flatness value to drive. There's a few different ways to do this, so don't take this as the end-all to be-all message. However, I feel like this is a really good highlight to show the key aspects of performance when it comes to the Artec Space Spider. So let's take a look at the results that we got. And we can see our standard deviation values, our max deviation values, as well as I took an average value and our maximum deviation from our average value, just so that we didn't just primarily use the assumption that the block is 1 inch, 2 inch, and 3 inch. So if we look at our standard deviation values, we can see the highest value that we have on that is right at about 1.7 thousandths of an inch in standard deviation. for our max deviation value, which would be the maximum deviation from the part if it is precisely 1 inches, 2 inches, and 3 inches. And that's right at 2.6 thousandths of an inch on the 3-inch mark. And then if we take our average and look at our maximum deviation from average, we can see the maximum of those values is about 2.2 thousandths of an inch, or 0.00218 thousandths of an inch max deviation. However, there's one more value that we threw in there, which is flatness. So let's analyze that flatness value a little bit, because we can see that those values are quite lower than the 1 inch, 2 inch, and 3 inch values. So if we create a 2D comparison here and just take a slice of our part and look at that slice with a whisker multiplier, we can see that whisker multiplier is set to about 50 times the actual value of that noise, just so that we can amplify it to see it. We can see when we set our tolerance at right at 1/1000th of an inch, that overall flatness value on the two surfaces that are precisely aligned to our part are extremely low. So we're dealing with less than 1/1000th of an inch of a deviation based off of noise of the scan surface alone. So the takeaways from this really are, when you're dealing with a worst case scenario type application, like something such as a 1-2-3 block, where we don't have a lot of geometry that we're working off of in the processes that we use, we still achieve a very tight accuracy value with the Artec Space Spider. And then when we come in and actually look at a surface analysis to really see what the scan quality is like from a noise perspective, we can see that those values perform exceptionally well. So thank you very much for taking a look at this video. If you have any further questions regarding the accuracy of the Artec 3D scanners, or any other questions regarding your inspection or reverse engineering needs, feel free to give us a call.